opportunity. And my name is Walid Shari. I'm working for Amazon Web Services, AWS, as a generalist solution architect and affiliated with the cloud native community in terms of meetups. And we ran the EMEA Kubernetes Community Day last year on Dubai on JITEC with DevSlam. Other than that, it's been a hectic year, and I'm trying to get back to the community and trying to refresh on containers, Kubernetes, and everything cloud native. I used to be part of this book club before with Eric and Carlos. Can you hear me well? Is there any question?
We can hear you well. Can hear you well. Yes, all good.
Okay. Sorry for the setup. I mean, I thought that I would be connecting from home, but I had to stay a little bit more. So usually before we take our time in the books and on the chapters, and we discuss a lot. But now I guess that I'm trying to get the book. Just a second, I need to share also. So I tried to prepare a demo, but I didn't complete. Let's see, production Kubernetes. So what I like about the book is actually the authors. I know the book is a little bit old, but their touch is still there. Why they made the trade-offs, what decisions they took. And if we remember, how can I share my screen?
Yeah, you should have an option of share screen somewhere in the middle of the screen. Yeah. Are you able to?
Yes.
Okay.
So you see my screen, correct?
Yep, we can see.
It should be observability now, but it doesn't. It doesn't change.
We see the OpenShift, Red Hat OpenShift.
Yeah, I changed the tab, but it doesn't change. Maybe I should put it screen. Entire screen.
Yep, again.
So the chapter is about observability. And the term observability, it can have different meaning in control engineering than it is in the cloud native. But in the cloud native, it was coined by Honeycomb, actually. And it means three things. It means that you should have logging, metrics, and tracing. But why? We need to ask why. The thing that, why do you want this? This is a day 2 operation. This is a day 2 task. This is something before you go to production, you should make sure that you have it. And the main reason is that you need to have actionable insights. If you are running a production, expect failures. Failures happen all the time. So you need to have alarms, you need to have dashboards, and you need to have basically history of your change management and other stuff. Logging, most likely you will have it. Most likely all our traditional system and our modern system are guaranteed to have logging. Metrics, you can have them from logging. Tracings is something that we don't see a lot, but we see it becoming a trend, especially with people that are running service meshes or running distributed systems and allowing tracing solutions to figure out performance bottlenecks, to figure out how the problem before you had the monolithic. So it was easy. You don't need to do any networking. But now you have microservices. The more microservices, the more containers, the more bots you have, the challenging the network becomes. And if this is distributed across nodes, it becomes more challenging. If this is distributed across clusters, it becomes even more challenging. So this chapter is about the observability and the requirement of observability.
So I believe in the recent discussions, I mean, the profile is also being added as an observability, right?
The what, sorry?
The profiling of CPU and other stuff, right? So earlier there used to be these three things, but now I think people are talking about profiling, like JVM, CPU profiling, also as a part of observability. That is also, I think, becoming a trend. Yeah.
I saw something around this. I saw a company, they have a solution around Greg Brandon. Do you know Greg
Mm.
Brandon have this
Yes.
method of use case, and they have he has this open source solutions where the fire, basically he can figure out the system calls and where the performance bottlenecks uh, down to the dependencies, to the libraries and stuff like this. But
Right.
yeah, bro, yeah, I mean, the reason for this is to keep me honest. The book is 3 years old. Most likely there are new trends. And I have seen this. I have seen that there are companies, especially on the Java domain for the enterprise, are doing this kind of performance enhancement using profiling. Yes. So
Yes.
again, we have to remember why we're doing it. I mean, if you are a platform engineer, you are not doing it just for the sake of satisfying a check mark for compliance or for SOC 2 or for whatever. You are doing it for a reason. And the primary reason is to have actionable insight, to enhance performance. And these are the three areas where you have to cover. But if profiling is one of the areas that will allow you to have actionable insight to enhance your performance or to do troubleshooting, most likely it will satisfy the definition of observability. Yeah.
Right.
Um, in the examples that I tried, so what I did, I used this one. This is one of our open source samples under
Mhm.
AWS samples, Open
This is
Observability Demo. It's quite intensive in terms of it's not just Kubernetes, it's ECS, the container service, and it's DynamoDB, the NoSQL database. So that's one reason why I selected it, because observability, like other things in the cloud native, sometimes it's not just Kubernetes. Like when you have, what's the difference between Oba and Kivarno, for example? Yeah, one is like focused on Kubernetes, the other one is focused on the whole holistic system. So do you want it really to be just Kubernetes? You want it end to end. That's why I selected this application. And if I look here, I have somewhere here the application. So this is the application architecture. So it's a lot of services. User come through a load balancer. They hit the front end in Kubernetes, and they have like SNS. So basically, they have simple services and like queuing. They have serverless. They have event step functions, and they have storage, object storage. So there is everything almost. And to do the observability here, there is a managed service for tracing, a managed service for logging, and a managed service for open source Grafana, and managed service for open source Prometheus. So there is metrics, there is dashboards and alerts. Grafana, you can think of it as both. And there is logs and metrics also from CloudWatch. I mean, you could argue that Amazon CloudWatch and the AWS X-Rays are enough. And this is one thing you will see in the implementation. So in the book, he doesn't want to talk about the storage or where you forward the logs. Okay, usually it depends on your cloud or in your on-prem. You will have Splunk or you'll have a solution, Elasticsearch, OpenSearch, whatever. So in the book, they don't want to mention this because they said different people have different choices. Let's go to the book. So logging mechanics. Before, in the traditional monolithic, each application was responsible for logging, and they send, if it's a Linux system, to var log messages, maybe specific directory, like in Apache, it has a specific directory, and different files, like error files are different than the normal logging and stuff like this. And maybe different domains will have different areas on the file system. However, starting before containers time even, we started to see that services starting to log out to standard in and standard out as a convention. So that basically you want to decouple. You don't want if you think about logging and application design and distributed systems, you will hear the word non-functional requirements. I don't agree with this word because, I mean, if we don't have logging, we might not have troubleshooting, and most likely the application of the distributed system will not be working. But this word is there for the things that the developer should not focus on. They shouldn't be the developer or the end user should focus on the core function of the application. So anything that is not core function is usually, like security, for example, is considered non-functional. So you want to decouple these things, which are day two for platform engineers, and take the overload from the developer or from the end user to the platform engineer or the architects and stuff. What are the problems from the traditional versus the modern? So they highlight one quite challenge, that the containers are ephemeral. So it's not guaranteed that I will have the container long-lived. And the other thing is the number of containers. One deployment could, for resiliency reasons, for high availability reasons, for self-healing reasons, for rollouts, for lifecycle management, it's always better to have 2 or more replicas of any application. I mean, I always argue with people that are migrating to Kubernetes, to the cloud, to a CNCF system, that even if it's a monolithic, it's better to be run in Kubernetes because you'll have the health and the health readiness and startup monitoring, and you'll have the recovery. You'll have self-healing, even if it's monolithic. But if you want resiliency, if you want high availability, you have to have replicas. And replicas add to the complexity of logging. Because if I'm logging for one, which pod or which object in Kubernetes that caused the error or caused the performance slowness? Is it the deployment, or is it one pod that in a bad node, or is it the node? Is it the pod? Is it something related to the configuration of the deployment or the stateful set or whatever? And they talk about log aggregation because it becomes important. Your deployment in Kubernetes, if you really consider all facts, it's challenging. There are many bots, there are many deployments, there are things related to the platform itself, the Kubernetes system itself, there are things related to the control plane, there are things related to the data plane. And the data plane most likely is running more than one namespace, running more than one application. So you need to have some kind of grouping, you need to have some kind of aggregation, and you need to have some way to analyze all of this. Yeah. So these are the challenges. And they reference also the Kubernetes API server, because we all know by now that the API server is like the gateway, is the broker, is the core function in the brains of Kubernetes, in the control plane of Kubernetes. And it can be hammered by the number of API requests. So whatever you, and that's one thing I like about this book. When they make decisions, it's not just a decision for the function or the distribution. It's an overall decision. Okay, like I have the API server, and I know whatever I do most likely will make an API request to the API server. Do I need to audit these requests and stuff? And they will talk about them later. So they start with container log processing, and they mention what they have seen. They have seen 3 cases. the application forwarding, and this is usually the mindset of a traditional app developer, where they take on the responsibility over them to do everything, logging, security, and developing the core functionality, and they think this is not valid anymore for modern cloud-native applications or cloud-native logging or cloud-native observability. They talk also about the sidecar processing, which has been seen before containers. Would start off the service-oriented architecture, were basically from the software engineering things that we learned from them is that it's better to decouple the functions, better to decouple the services, so that you can manage them autonomously. So one server, and the moment you do this and you focus on your core function, the non-functional requirements can be shared with all these functions, with all these applications. So you solve the logging problem once, you solve the security problem once, you solve the other non-functional requirement once, and they can be applicable to many applications, and they can be enhanced, and they can be updated separately than the core application. And sometimes you depend on the cloud provider in doing this. So this is one of the news, by the way, one of the news that we have Prometheus agents, agentless for monitoring. This was before reInvent, I think 1 week, which is good. So you don't even need to install an agent or a sidecar. Node agent forwarding. So in this case, with the sidecar, that means every pod will have a sidecar, will have an extra container or one or more containers that take care of logging. Okay. Is that good for the API server with all these requests going straight to the API server? Or there is a way to reduce the overload? So there is this new pattern, the node agent forwarding, which is used in Fluent Bit, for example. So instead of the containers communicating directly to the API server and sending their logs, forwarding to logs to wherever, maybe you can centralize the logs on your Kubernetes nodes, and then you send them to an aggregator at cluster level, or you send them to the API, or basically send them to the backend. So here they talk.
So quick question there, Walid. So why would the sidecar would send the log to the API server?
Okay, so any verb, everything that is done will be a request to do something, correct? Like let's say I'm doing kube control logs or something. So this will go to the API server as a request, and it will see. Now you can argue in terms of functionality. Let's say there is a container that is. Let's find an image. So let's say that I have this one, okay, and I have a bot that has a container, and this container is writing to a log file, and there is another container that is a sidecar that is reading from this one, and it needs to send it somewhere. How this gonna happen usually? How do you do this? So most likely you will have a config map with a configuration that says forward this log, for example, to CloudWatch or to Splunk or to wherever. Yes. Now, so what are the consequences of having it this way? What are the consequences of having it this way?
So in the other case, when sidecar container is there, I believe that sidecar container would send it to the destination directly, right? For example, if you have given the endpoint of Elasticsearch or something like that, right?
Correct.
It would directly go there. So I don't see API server coming in that particular flow.
Yes.
So that would not be the case. That's what my understanding is. That should not come
Yes,
in
yes,
that
yes,
flow.
yes, yes. It wouldn't be. It wouldn't be. Okay, it would be only when recreating the pod, because there is an not really even. It would be, yes. I need tracing to to debate this. I need to have enough tracing to see this.
No, so I mean, so sidecar container is going to add an extra container on your pod. That is the consequence of that. Other than that, I think once we have configured in the config map where to go, it will
Yes,
just send directly to it. So API server would not come in that flow. Only when you say that, okay, I want to the kubectl logs command to see the logs, only then it may come. But
yes.
for sending the logs, it should not be an issue, I believe. Yeah, it
It
says that
wouldn't.
the first point here, right?
It wouldn't
Uh,
be an issue. Yes, it wouldn't be an issue, especially if it's a light container. And yes, I guess yes. Here they say for this pattern, the sidecar, they say that this approach is uncommon, and they see it used as a workaround where there's no log aggregation system. So you would think that this is a common logging pattern, but and that's what the thing that I said I like about this book, because if you are new to the cloud native, or if you haven't done diverse consultancies or stuff, this is basically their experiences, the three authors' experiences distilled in like small sentences like that.
mhm, right.
Let's see. In situation where the sidecar writes the log to standard out standard error, it does so to leverage node agent forwarding. So this is the other pattern. So here he doesn't mention yes. So I assumed this, sorry.
No
So
worries, no
that's
worries.
why I
Yeah.
said
That's why we're learning here. That's okay, not a problem. Bhavan. No, not a problem.
so I assumed this, yes. Um, the node agent forwarding, which is the most common one. So you will have like a daemon set, and this daemon set makes sure that each node will have a node agent forwarding, and this node agent forwarding, they say 3 years ago it was FluentD or FluentBit. I believe also there is Loki, but I'm not sure how it is done. Maybe I can find out. So basically, but FluentBit is very quite popular. At the time of their writing, he says that there was not enough agents, and they were suggesting to use FluentBit at the node level and
Mhm.
FluentD at the cluster level to make up for this. Okay, so that basically FluentD can enrich the events before they go out to the back end. Nowadays, I believe, what kind of plugins? It's basically where you can read from, where you can write to, if you need to do filtering to the data, things like that. And he mentions the differences between FluentD and FluentBit. FluentD is a little bit heavy because it was written in Ruby. FluentBit is written in C, and it was made lightweight. This was part of the requirement. So it is a small footprint. It's small on the CPU. So in general, it was written to be like an accessory that with less overhead. And this is the architecture that they think is most commonly used. So at the cluster level, you have FluentD, and there is a recommendation that to run it as stateful set for resiliency purposes, for production resiliency purposes. That is that if you run it as a deployment, and the bot that is doing the logging or doing the processing of the logging um dies or terminates for any reasons, and most likely it's using in memory, so you will lose this. Um, so basically, yeah. But if you are writing stateful set, most likely it's writing to persistent volume. So that's where they say it here. Can flush the logs from its buffer. So it doesn't, if it's a deployment, it will not have time uh, to flush basically the logs, and you might lose some logs. And maybe these logs that you lose are the important logs that you wanted. Maybe this is for financial or regulated industry. But there is an assumption also always that maybe some logs will not be there. They are,
So is the fluentd is going to be used as a storage, right? Which I don't think so, right?
no. So fluentd will be forwarding the logs, the log events to fluentbit will be on each node. So imagine this is just one node. Yeah, this one is just one node here.
Mm-hmm.
And fluentbit, you don't want to use persistent volume. So most likely you'll use something in memory like empty directory or something. Yeah. For two reasons: for speed and because you are not really doing anything, you are just forwarding. So you're forwarding it to fluentd, and fluentd could add metadata like labeling or adding because it will have more plugins, it will have more functionalities. This was 3 years ago. Yeah.
Yeah, of course, of course.
Yeah. So now you could argue that whatever, I don't need to enrich my data. FluentBit can do it straight away. Yeah.
Yeah.
And then it can forward to one or more logins. It can, for example, maybe it is forwarding to Splunk, maybe it's forwarding to CloudWatch, maybe it's forwarding somewhere else. I don't know.
Understood.
Like, yeah. So here, so they started with the patterns. Which pattern should you use? And most likely you will stick to this pattern, the pattern that the fluentbit on the node.
Yes.
This is the most common. Yes. I didn't see any comments, so I don't really know. Okay. There's no question, there's no comments. Folks, basically chip in. Okay.
Yeah, that's what I want to make it more interesting. So please either put on the chat or speak up. Both are fine. Yeah.
Yes. I mean, if you have seen something in your clusters in production or in testing, or you are trying something different, or logging is important for you, or observability is important for you, and it's done different than what the authors say, please talk about it. Now, Kubernetes audit logs, these are very, very important in production for several reasons. One reason is that who did what? Every action that happens in Kubernetes basically gets logged. Okay, and that's too much. And actually, this is one of the questions in CKS. This is one of the domain areas in CKS. So in CKS, you need to, because in terms of security, I mean, for security reasons, you need to know if somebody is trying to read a secret, watch a secret, or get access to a secret, or get access to config map. Was this a service account? Was it authorized? Was it not authorized? Where did it come from? This is where you find out in the audit logs. So for example, in AWS, we have CloudTrail. This is where you see basically every API function that was used. In Kubernetes, basically it's the Kubernetes edit logs. And if I go, do I have this? Like, if I go, not this one. If I go to EKS, I am in EKS. If I go, for example, observability here, you'll see that by default, it's not enabled. So what you do, you say manage logging, and you enable audit logs. Okay. In other, I mean, if it's not managed Kubernetes, you have to, it's an option to the API server to enable the audit logs. And it's too much. It can log too much. So what do? You write an audit policy. And in this audit policy, for example, one thing that you don't want the response for secrets to be logged in clear text, especially, unless you have a system of logging that masks these sensitive data. So in this manifest, okay, it's audit K, IOV1, so it's quite stable. I'm not sure what's the latest API version for this, but most likely it's the same. We can check. So the object resource type, the API, is policy, and it defines certain rules of how you do the logging. Let's take this one because it's an important one. So the logging have like 4 phases: request received. I forgot the other 3, but basically it's request and response. So basically, from the moment the request received until the response is emitted out, you can log each phase. You can define what you want to log, what you don't want to log. So in this case, it's saying for any group, okay, if the resource is secret or config map, you want to log the metadata only. So the metadata will say who, where, but it will not give data. It will not give the body of the secret or the body of the config map. And here they make sure that even the request received, it will omit it, so that you don't see, basically you're trying to hide the sensitive details, this section. So metadata, it's only the request metadata is logged. And this is good. This is good for both, for sensitivity and for size. You limit the size of what you are logging. And they do this also in here. On the there is another example. For the verbs get, list, watch, I mean, especially if this cluster has like the number of resources for get, list, or watch, like let's say it's a large cluster, large number of nodes, and you are doing get nodes. This is too much. You don't want to log get nodes minus OY. You don't want all of this, or get bods minus A, capital A. You don't want to log the response. You just want to log the command. The command is good enough for you, for your logs, for your inspection. Yeah. But for size, for management of resources, you want to omit the response. So he's omitting the response here. And if you are going to do the CKS, I believe this is an important section, actually. I'm not sure because most likely it got updated several times now.
No, but this will be there for sure. It's a good question to have. Yeah, it would be there.
It will be there.
For sure. You can't skip it.
I mean, it's not just the CKS. If you are doing security and you want to manage your resources, it's better to spend some time on that. Now, you can argue in managed services, you don't have control over that. Most likely you won't. Okay. But the good thing about managed services, it's managed services. So the SRE of the managed services will be actually handling this in behalf of you. So don't worry. But you will have actually at least the audit logs that you really need.
So you're saying that in the managed service, of course, we'll not manage this, but we would be getting the audit logs by some interface, right?
Because you need, what do you need? Yeah, I mean, for managed service, for things like the SREs wants, they will get them. But for you, for example, you want to get the metadata. So most likely they will provide you with the metadata and stuff. Yeah. Right. But you don't want to get the responses and stuff like this. So most likely they will provide you with what you need. And if there is a use case that you think that they are not providing, most likely it will be like a feature request on the roadmaps or something. I haven't checked, but that's a good question to check, really.
Okay.
Kubernetes events, and that's why I have the OpenShift. So different distribution, different Kubernetes distribution, they handle these things differently. And one of the important things is Kubernetes events. But one problem with Kubernetes events, that many people don't know, that the events, the most important events, live for 1 hour. So if you don't have a mechanism of storing them or mechanism of exposing them, you won't see the trigger of the issues or the things that you're looking for. And if you watch raw code clustered sessions, you'll find people that are trying to break the cluster. They make sure that the events are gone. They make sure that whatever traces they have are gone. So this is one thing they do. And when you do kube control describe, part of the describe, it will get the relevant event related to what you are describing, be it a bot, be it a deployment, be it a node. For example, and they are giving an example here. But if you do kube control get events, and for a namespace, it will be for all the context within this namespace. Now, I remember actually one of the previous audience when we were doing this book. This book, you will find the namespace default many times. But if you read the security, the best practices for Kubernetes, the first thing you need to do is not use the default service account and not use the default namespace. If you have a new application, it should be on its own namespace. The application has to have its own service account. You don't want something that has been there or default assumptions to be used. And I saw this in several actually examples and several books. Try to avoid the default namespace. Don't deploy on the default namespace. Always deploy on a new namespace so that you control everything inside it. And they are suggesting that, for example, you use Prometheus, use something like, what is it? Yeah, you use Prometheus, like an event exporter that basically exposes the metric to Prometheus. Yeah. I have an OpenShift. So people that are not familiar with OpenShift, they have something that you can use for 1 month, and you can use Cloud Casa or any backup services to back it up, because after 1 month, you will lose it, and you need to start from scratch again. And however, what I like about OpenShift is OpenShift, the abbreviation for it is OCP, Open Container Platform. But some people say it's operator container platform because everything is an operator. And one of the operators installed in this sandbox is observability. So every day 2 operations, if you want to enable day 2 operations, for example, observability, you just install an observability operator. In the sandbox, it comes installed. If you want to enable GitOps, you install the GitOps operator. I believe it's also installed. So they have the pipelines, which is Tecton. They have GitOps Primer. They have a developer environment, dev spaces. Anyway, when we go to the observability operator, let's see. Where's the observability? This one with many eyes, or I don't know, it's this icon. You will see that they have something to monitor the bots. There are probes, but we have Prometheus. We have the alert manager. We have scraping. We don't have Grafana. So basically, this is about scraping. This is more about metrics here. And you can do metrics at small scale, and they have Thanos. So most likely that if you want to do it at more scalable scale. Yeah. Anyway, we were talking about events. So why I am here? So in OpenShift, you have 2 user interfaces, one for the developer. I installed a quick application. It's just one container, one bot, 2 deployments, 1 container, 1 bot. And if you click here, this is the things I like about OpenShift interface. If you click here, it will bring this side. Come on, it will bring this side tab, and it will give you details about what's this. So it
Mm-hmm.
says scale to 0. Why scale to 0? It will tell you what's the name of it, the namespace that it's running, any labels. You can edit the labels. What's the bot selector for the deployment, tolerations, whatever. So this is very good, really. I mean, very quick to, this one because it cannot run, so this one is the one is running. Okay. So you have lots of things when it was created and stuff like this. But what I like for our chapter is the observe. And guess what? I cannot observe anything. Huh? That's strange.
Is it running?
It is running. Let's go at the bod
Yeah, it
level.
is running. Yeah.
Let's go at the bod level and let's see. So yeah, there are metrics. So we can see memory usage, CPU usage, uh, things related to the file system and the network. Usually that's the things that you need to see. Okay.
Mhm.
And we can see logs. And we can interact with it if it has an exec, if it has a shell or something, which is not really recommended. I'm not sure how they're going to do it for the ones that doesn't have shell. But for our section, I'm interested about the events.
Mhm.
So the events are here. And you can tell from the color usually and if there is any issues or not. So there is no issues. And you see the history of the event, how this bot was created. Yeah. So this is one thing that I like about OpenShift in terms of observability. I don't have so the reason I chose the sandbox because I wanted to be a developer. I don't want to have administration privileges. But if there is an administrator, they will have many dashboards for the cluster and for the applications. But I don't have it here. Yeah. But for any pod, you can check basically things like what's happening. And I don't know why on the topology why it didn't work. Observe maybe, yeah. So let's say, so you see here on the observe, for this namespace, you see certain dashboards, yeah?
Mhm.
And they are by default. You don't, yeah, that's another good thing that you don't need to worry about what dashboards I need to customize or whatever. So they have the default dashboards, and so this is how you want the book doesn't really mention it a lot. It mentioned it in a couple of places, but you need alerts, you need insights, and you need dashboards, because this is how you do your anomaly. This is how you find out if this behavior is like this spike, is it normal or not? It's not normal. Why did it happen at that time? Sorry.
So with that point, I think there's one more
I don't
discussion,
know what
not
you're
in
going
this
to say.
particular book, but there is another book from Honeycomb which you mentioned earlier, right? There
Yes,
we are mentioning
observability.
about difference between the monitoring and observability.
Yes,
Correct. So I think monitoring, and then that's why kind of if you kind of double click on that, right, you'll see that the existing tools, whatever they are earlier, right, which were not built for the microservices ecosystem and so on, you
yes,
cannot basically have this kind of detection or kind of a post-mortem which you can do right now with observability earlier, right? Because earlier you just get some data, but now because of the observability which connects everything, you kind of get all the information, tracing, logging to a point. And why I
yes,
kind of bring that point right now, because they're showing that graph right now, right?
yes,
In that graph, uh, is that normal? How do you know, first of all, right? Like, unless you have the old data and to compare, we can't figure out that it's normal or not. So, anyway, I think we'll discuss later some other time on that
yes.
topic. Yeah. Go ahead, Bal. Sorry.
So yes, I mean, if you want to learn more about observability, just follow Honeycomb and follow and read their book and check their keynotes. They usually give keynotes. They gave keynote last reInvent. You want the data correlated. You don't want the data separated. You want basically the metrics, the logs, the logs, and the metrics coming from the logs, and you want the traces connected together. And you want it to build like this. Like, for example, this is from CloudWatch under application monitor, because you're not you're monitoring the application. Okay, now the platform engineer might be monitoring the system, and you want a dashboard that tells you exactly, like here, for example, in CloudWatch. I like that because basically quickly I can tell how many issues I have. I have 2 alarms, and I have 38 events that I'm monitoring that are reporting back correct, because if it's not reporting back, then it's wrong. So I need to know if it's green or red. But when I come here, for example, in this map, I can see that I have services that have issues. They are still performing, they are still working, but they have issues. And the moment I click on them, I can see what the issues are, or I can go to their logs. Now I'm looking at the dashboards and metrics, but maybe I want to check the traces, how the issues happened. I want to have more context. So basically, when I go to this is X-ray, which basically the traces. So I can see these are the 2 endpoints and the performance of them and the percentages and stuff. Maybe this one was not a bad one. Okay. But yes, I want the correlation and I want the relationships between them. So this is for the logging. And I think it's a nice touch that they add the events to the logging, because many people, I'm not sure, but I see many people, I was troubleshooting with one customer, and they don't look at the events. It's always good to look at the events and have keep track of them. And you can alert on logs, but you don't want to do that. I don't have the administration interface of OpenShift, but why you don't want to do that? Because you cannot have rules on how often this alert will be triggering on. So it's better to create metrics from logs. That's what they are saying here. And from these metrics, then you do the alerting. And that's how the alert manager works. Security implications, as we mentioned, anything you're logging, make sure that it doesn't have sensitive data. If it has sensitive data, there are tools that can help you with masking this sensitive data, especially before sending it to persistent or to back-end storage. And even if you are sending it, make sure that you are doing security TLS, that you're doing security in transit and at rest. Now we go to the metrics. And I was looking for the word insights. I find it only twice here, because basically for me, observability is about actionable insights. And one way to get the actionable insights, as we've seen on CloudWatch, is that by having alerts, and these alerts are based on metrics, on percentiles, and what is your service, and you have to define like a service level agreement or service level objectives, and that's what the other book is talking about. They talk about, okay, I have a different point of view of the world than what you have. What is correct, what is wrong? So you have to have some kind of a baseline. You have to have some kind of an agreement with your customer, with your users, with the other teams that you are working with, to decide. And you have to have it from the application point of view. Yeah, I mean, I had a problem with one auditor before. I was working as an HPC specialist. And in HPC, we wanted the system to be utilized full time. So we have a scheduler system, like here in Kubernetes. And you try basically, most of the jobs are batch jobs, and you try to utilize as much as possible of the nodes. And the nodes usually they are compute intensive workloads. So this auditor, he had like a control that says if the system is above 70%, that's overutilized. But this control is not applicable to HPC. So you have to agree on the controls, on the metrics, and what is important for this workload.
Right, agreed.
Yeah. So in this section, metrics is very important. And the de facto for microservices orchestrator is Kubernetes. The de facto for metrics is becoming Prometheus. And why? Because anybody can write an exporter to Prometheus. As long as you can describe it in digits, Prometheus can take it. And that's the second one where I found the word insights, meaningful insights. So I don't just want meaningful insight, I want them to be actionable also.
So how many of you, oh sorry, just want to get a general question. How many of you use Prometheus also on the call right now? How many of you used Prometheus earlier? Anyone use Prometheus?
You can raise your hand, you can use the voting, or you can just say yes, or you can talk, by the way. I don't think you're blocking the.
Yeah.
Would like to hear your voice.
Hey, I have used both self-hosted Prometheus as well as the managed Prometheus instances. Yeah.
So for managed one, which one did you use?
The Azure managed Prometheus instance.
Okay.
And any limitations, any positive things you'd like to say about your experience, this versus that? On
Yeah,
the managed one, were you the gentleman managing it?
sorry, can you come again, Wally?
You had two environments. One was managed by the cloud provider, and one was not managed by the cloud provider. So who was managing it?
Not like that. So basically, initially we were using the self-hosted Prometheus, and we were controlling the whole setup. But going forward, because it was getting difficult to manage the Prometheus instances when it came about scaling, and we didn't wanted to take the whole responsibility of managing those instances and infrastructure. So we decided to pull in the services provided by cloud providers. So one of the options available for us was the Azure Managed Grafana instance, and it comes up with the managed Prometheus instances. So one of the things is the cloud provider is responsible for managing the scalability of these instances. But whenever we are scraping this matrices, it goes to a single Prometheus instance, which gives us more control on the way we handle the multi-tenant architecture base customers across like different like multiple clusters. So that is one definite advantage for us.
Yes.
So what you're saying is when you query the data from Prometheus, it used to give you the output of one instance. Is that what you're saying, or?
So initially what we were doing was we were setting up Prometheus on different clusters altogether. Like
Okay.
each cluster would have its own
Okay,
cluster,
understood.
its own Prometheus. But now that we are using managed Prometheus, all the matrices details which are like scrubbed using the service monitors are been like dumped into a single. It's been basically handled by a single Prometheus instance.
Okay, that is understood. Okay, understood. Yeah. That way you are saying. Okay. And what I so challenge you said that you were earlier managing one Prometheus per cluster, and I assume that you install the Prometheus on the cluster itself or outside.
Sorry, I didn't get that.
So when you said that earlier that you installed Prometheus, you were having one Prometheus, one cluster, correct?
Correct.
So I assume that you were deploying that Prometheus in the same cluster, or is it outside?
Yes, within the same cluster.
Okay. That and then you were trying to kind of do the federation of that, and that was become challenging maybe.
Correct. So basically, we were considering the Prometheus as deployment itself.
Okay.
Within the cluster, which was ideally not a good approach.
Yeah, it should be, because if the cluster is down, then what you'll do? You can't do anything. Yeah, so it should be always out. Okay, understood.
Nibandra, you reminded me now of the earlier questions. Why would a sidecar cause more requests to the API? So the way we install these day 2 operations, like in Red Hat, we install usually an operator. we don't really go like we install a Helm chart or we install an operator. For me, it's mostly operators, and the operators have controllers, and these controllers they if it's a good operator, it will check like so one thing mentioned was the scalability, but it's not just the scalability. When you choose a managed service or an operator, it's the scalability, it's the upgrade, it's the updates, it's many other operational things that it takes care of. And some of these operators are not really very good. And if you monitor them, if you have metric, how many API requests are happening and where they are coming from, which namespace or which deployment, whatever, you will see that like FluentBit, actually it was FluentBit. FluentBit, it has two options when you install it. It can send to the API server or it can send to the kubelet. So there is an option in FluentBit that basically will reduce the amount of requests it's sending to the API request. So maybe somebody do this exercise and research this configuration option and why it was there. Because it's really nice that if you, instead of overloading the API server, you relay functions to the node as in a kubelet or as in the runtime. Yeah. So you just reminded me, I mean, now.
Okay, that's good. Okay.
And the thing about the Prometheus, you don't usually see it alone. You usually see it with Grafana. And you get Alert Manager for free. So basically, Prometheus Alert Manager and Grafana always together. And that's why I was wondering why the observability operator in Red Hat doesn't have Grafana, but maybe it's segregation of operation, which is good for security, but I'm not sure. I don't really know what was the decision there.
Okay.
When it comes to long-term storage, as we have seen in the operator of Red Hat.
Well, just sorry to bother you. So I think we have closed our time right now generally. It's like 1 hour we have done. So should we move it to the next session now with this particular topic?
Okay.
Because we've been
how many we have? How many? 11.
Yeah.
Do you want me to start with like a workshop, and we send the link to the people to do it like beforehand or something?
Yeah, it's your call. It's your chapter. You take a call. that's
I mean,
how.
How do people? If you like this option, you can raise your hand. You can select the raise hand so that we see how many people are interested on participating in a workshop. The workshop might take 2 to 3 hours. It will. Okay. So how many we have? Oh, it doesn't say. It doesn't count. I have to count them.
Yeah. So one other thing is that people are watching the recordings later as well. So basically, we can't just rely on this. But of course, doing a workshop would always be good. And maybe we can plan in advance and then do it. Tell that there's a workshop which we kind of make more than 2 hours kind of a thing. We can plan that out and we can broadcast it so more will join for sure.
No, I was thinking giving them the link in advance.
Okay.
Yeah, I don't know how you can do this. Do you have mechanisms to send them the link in advance?
Yeah, I can send an email to everybody who have signed up so far on this particular group. So I can do that.
Okay, so check who is interested, and we can send them the link 1 day in advance, let's say, so they have time to do it alone. And then
is it a paid link or is it like how is it? What's the link?
No, it's what do you mean?
Is it a paid link? Like some paid link is there? There's some info required for that to finish?
No, it's a self-contained workshop in AWS Cloud.
Okay, then we can do it in general. No need to kind of ask, right? We can just broadcast it. This is a workshop, and it would be better if you come next time after finishing it. That's all. No need to kind of do two things. Just kind of we'll just drop them a note. This is what we are doing the next time, and please finish this thing before we come. That would be better for discussion. That's all. I believe so.
Okay, but it will take longer than 1 hour most likely then. Or we focus just 1 hour on the we are in do we start with Prometheus or we start with the tracing or what?
So we start where we left off right now. So we can do in two ways right now. We can either finish our content the next session, and
Okay.
then we do workshop week after that. That's okay.
Okay. Let me
Then
okay.
so you can decide. You can let me know, and then based on that, I can drop them a note. Yeah, because I think it will take one more session, I believe, to cover the theory part, right? So Prometheus will take some time, I believe, right?
Okay.
Yeah.
So we can cover Prometheus hands-on next time, and
Yeah.
we refer what decisions are made, like the long-term storage, like they are using. For example, Red Hat have selected Thanos versus Cortex.
Mm-hmm.
So these are the two primary options usually. Yeah. Okay.
Sure.
Thank you all, and sorry for the audio connection earlier on. I need to test it next time.
No worries. It was really insightful session, Walid. So I think it was good learning for all of us. Thank you. Thank you for your
Hopefully,
time.
yes. Thank you.
Okay. See you guys next week. Thank you, Walid, one more time.
Thank you. Thank you very much. Thank you for your time.